everyone! So today we're going to be talking about energy. So there are two main categories of energy. We have kinetic energy and potential energy. Kinetic energy has to do with the energy of motion. So all of those types that are under that category, we have mechanical kinetic energy, thermal energy, sound energy, electrical energy, radiant energy. Those are all types of energies in which things are moving. Potential energy, on the other hand, is stored energy. So energy can be stored in chemical bonds, in nuclear reactions, gravitational potential energy, and elastic potential energy. Now, in this little presentation today, we focus on three main types of energy in physics. That's mechanical kinetic energy, gravitational potential energy, and elastic potential energy. So potential energy in AP Physics is denoted by a capital U. If you have taken my CP class before, you have seen this as just PE, but in AP we actually use a capital U for potential energy. Don't ask me why, I don't know. Now the fancy definition for potential energy is energy that can be associated with the configuration or arrangement of a system of objects that exerts forces on one another. Now that's a mouthful. So really, like I said, the easy definition for this is potential energy is just stored energy. And it's stored by virtue of position here. So we have two types that we're going to talk about. Like I said, we have gravitational potential energy, which is the energy associated with the state of separation between two objects that attract each other by the gravitational force. So for example, we have a bungee jumper in the earth. Now we have the earth here, bungee jumper is up here. We know that that bungee jumper has a force of gravity on it that's going to pull it down to the earth because of the earth, right? Now this is the arrangement of the objects, and because of this bungee jumper is up at a certain height h, it has gravitational potential energy. Now, elastic potential energy, on the other hand, is energy associated with the state of compression or extension of an elastic object, like a bungee cord or a spring. So again, we're talking about a configuration of that spring or bungee cord, and because of that configuration, that object might have elastic potential energy. So the gravitational potential energy equation is U is equal to M times G times H, where U is the gravitational potential energy, M is the mass of the object, G is our acceleration of gravity on Earth, which is 9.8 meters per second squared, and H is the height of the object. So we can see that the higher the mass, the higher the height, the higher the gravitational potential energy. For elastic potential energy, we have an equation that looks like this, that U sub S is our potential energy of the spring. So elastic potential energy, we could be talking about like rubber bands or something like that. Usually we are talking about springs in physics. So that's why we use S as our subscript there. K is our spring constant. So K is basically the measure of how stiff a spring is. So the higher the K value, the stiffer the spring will be. That is measured in newtons per meter, and you'll see values of K from like 50 to 4,000. Like they get really, really big too. So if you see a K value that's like in the thousands, don't be alarmed. That's normal. X is our displacement from equilibrium. So equilibrium just means like an unstretched spring. You can see in this picture right here. When we stretch this spring out, we can see that this was the equilibrium position right here, and this is our X. It's our displacement from equilibrium. So that's what you would plug in to your potential energy equation. Now, kinetic energy, last thing that we're going to talk about in this mini lecture is, like I said, the energy of motion. So if an object is moving, it has kinetic energy. The kinetic energy of the objects depends on the mass of the object as well as the speed. So that equation for this is 1/2 mv squared, where m is the mass, v is velocity. So you can see here that in order to have kinetic energy, the object has to have a velocity. If we don't have velocity, we don't have kinetic energy. Now, the units for all of these types of energies, the gravitational potential energy, elastic potential energy, and kinetic energy, the unit is called a joule, Joule. We denote this as a capital J. So I could say I have 10 joules or 10 J of kinetic energy or something like that. Now, a joule here we can see is equal to, I just covered it, 1 kilogram times meters squared per second squared. And this comes from the kinetic energy equation because we know that mass is in kilograms and then velocity is in meters per second, and that velocity is squared. So that's why we get meters squared per second squared. We can also see this work out too with our potential energy equation. It's mass times the acceleration of gravity times height, right? That's our gravitational potential energy equation right here. Now, mass, again, is in kilograms. Our acceleration of gravity is in meters per second squared, and then height is in meters. So meters times meters per second squared is meters squared per second squared, and then mass is in kilograms. So we can see that that works out, that joule is always going to be equal to the 1 kilogram times meters squared per second squared. And remember, all of those special units in physics are made up of certain base units. So our base units here are kilograms, meters, and seconds.